All right. Okay. X-intercept. We are looking for where we cross the x-axis. That is right here. I want you giving me both coordinates for that. So make sure you give me the x-coordinate first, which is going to be -1. And then the y-coordinate at an x-intercept is always 0. So we got -1, 0. Oh, excellent question, because I was being careless and didn't even look. Austin said, what about the other x-intercept? And he's exactly right. There is more than one. So I need to include this one as well. That one's going to be 8, 0. So there are 2. Sometimes you might have even more than that. Sometimes you don't have any x-intercepts at all. Just depends on the function that you're looking at. Y-intercept for this graph. Now, I think we're going to do a little estimating right here because I think that's a little bit below 2 there. So the x-coordinate of that point is 0. I feel I'm going to go with like 1.75. That is an estimate. I will not give you one on a quiz where you've got to estimate like that, unless it's just multiple choice where you can like rule them out, right? I will not give one where you got to type in for estimating on the quiz unless it's whole number values. So we would have 0, 1.75. For a function, can you have 2 y-intercepts? Okay, why not? It would not pass vertical line test. So if it had 2 y-intercepts, it would not be a function. A graph could have 2 y-intercepts, but it would not be a function if it did. Okay. Then they're asking us to do maximums and minimums. Okay. So absolute maximum is the very highest point on the graph, right? Where do you think it's at? Okay, at 4. Yes. And whenever we do this, we are going, the absolute maximum, when it's just, I could take either one the way it's listed here. You could just give me 4, give me the y-coordinate, tell me the highest y, right? If they ask what is the absolute maximum value, you would just say 4. It's the y that you're looking at. If they say where is the absolute value, maximum value, you might give the points. So you might have like, that looks like it's about 4.5, 4. So 4.5, 4. And a relative maximum, you're usually going to give the points. You're not going to give just the y value for that. Now, any absolute maximum is also a relative maximum. So I'm going to go ahead and write this down here, 4.54. That is also a relative maximum. Because if we think, again, like relative maximum means it's higher than the points around it, okay? So the graph switches from increasing to decreasing. So it's going to give you like a little bump like that. But what might happen is it might go back up. Is this the highest point on the graph? No, it is not an absolute maximum because it's not the highest point on the graph. But it is higher than the points around it there. But all relative maximum, all absolute maximums are also relative maximums because they're higher than the points around it. There. For absolute minimum, what do you guys think there? What's the lowest value we have on this one? Lowest y value? -7. So right around here, probably, we've got -7. Or we could give the coordinates of the point, which, let's just go with -7, -7. That's pretty close. It might not be. And since that is a absolute minimum. It is also a relative minimum there. Do we have any other relative maximum or minimums for this graph that aren't the absolutes? We don't have any other like little dips, right? So that would be all we would have for this problem. All right, let's do number 11. Okay, so for number 11, we've got to find the domain. Jalen, if we do the domain here, remember where, if you guys had, I know I didn't pass out your domain and range finders, but I'll get those to you in a second if we'll break up. But if we start over here and we go across with our domain finder, right? What number do we start at here? -3. Okay, so we got -3. Oh, I've messed up. What did I do wrong? It's a bracket because it's a closed circle. Make that a bracket. Okay, and then Jalen, if I keep on going over, what other number am I going to use? 8. Very good. Should I use a parentheses or a bracket with that one, Jalen? Bracket. Good. Okay. Range, we're starting from the bottom. So from the bottom, what is my lowest that I'm going to have here? -4. What do I go up to? There's my highest point. That is at 2. So we're going to have -4 to 2. Okay. If my graph is increasing, okay, which piece of the graph is increasing, Uriah? The left side or the right side? Right side. So this right side, if I'm looking like at this part right here, okay, Uriah, what's the domain for that part that I just highlighted there? Okay, so what we're looking at, we're kind of just doing like the same thing for domain. We're looking right here, right? We don't have any arrows on this problem, so we're not having infinity, right? So we're looking right here. What number on the x-axis am I at when I start right here? 2. And then I go all the way over here. What number on the x-axis do I stop at here? 8. So it's from 2 to 8. It's almost like you're taking it and you're cutting it vertically, like cutting that strip right there, and you're looking at what those numbers are. And those numbers are from 2 over here to 8. Like if we took the graph and cut it off right there. Yes, only x values, not the y's. So this would be, we were doing parentheses. Technically, you could use brackets if you wanted to there. There's some debate for that. Decreasing. For decreasing, we're looking at this side. Gage, what's that going to be? To 2. Very good. We're looking at those x values, right? Over here, here's where we start. The x value is -3. Over here, here's where we stop. The x value is 2, so -3 to 2 for that. Brian, is this graph constant? Now, that would mean it looks like a horizontal line, like a flat line. This graph is not constant. Is there some constant in number 12? Yes. 12 has some constant, right? We probably aren't going to do that one, but it does have a section that is constant. But for this one, we got nothing there. Okay. Next part's positive. Yeah, remind me, what's positive mean? Nope, that's increasing. Above the x-axis. They're really easy to mix up though, positive and increasing to think of. So we're thinking above the x-axis. So that's like, I'm going to do green on that part. That's this little piece. And this little piece. So we're going to have two separate sections where the graph is positive. Yes, your graph can be decreasing, but so think about your bank account, right? Right. So, but like, let's say currently, both of my boys are about broke. They have almost no money. Henry has $7, right? His balance, I mean, he doesn't have a bank account. I keep it for him because he loses everything. So it's like in an envelope that I keep. He has $7. His balance is positive, but it is decreasing because he's buying stuff constantly, and now he's about broke. It's about to be. So it can be positive, but decreasing. Now, if they would do some work around the house, I might give them a little money. They're refusing to do anything productive right now. But,
What about honey?
Not much either. He's pretty broke. Yeah, he's pretty broke. He has diminished his funds all summer long. Is what has happened. And he no longer has the money to fund his lifestyle, so he's going to have to make some changes too. But you could have positive and increasing, or now the bank's not going to let you get away with this for long, right? But you can have a negative balance. So like if you go use your card, if you have overdraft, if you don't have overdraft, they're just going to deny your card. But if you have overdraft on your account, and you have $7 in your account and you go spend $10 at Chick-fil-A, then now you got -3, right? So now you're negative and decreasing. So yeah. So yeah, sounds like you might also need some employment gauge. Yeah. Huh? Having a little hard time holding down the job. It's not good. but you can be positive but decreasing. Okay. So this little section right here. What's the domain for that section? The left side. Nope. We're starting here. Okay. What's the x? -3 to -2. And for this one, you're going to have, you're going to use a bracket here. -3, because at -3 you are above the x-axis, but at -2 you're supposed to use a parentheses, because when you have $0, is your balance positive or negative? Neither one, right? So we don't want to include that -2. And then over here, what is the domain for this other green part? 6 to 8. Yeah. So 6 to 8. So we will put the U right here to show we got more than one place. And we're going to use a parentheses with our 6 because it's on the x-axis. And then we'll use 8 with a bracket. Okay? All right, now, Isley, in between here, so like from here to here, our graph's below the x-axis, so the graph is negative. What is the domain for that section? Okay, we're going to start at -2. And then that goes all the way over to where?
Could you write this as going to 6 is still right?
You can, yes.
So 6.
6, good. Very good. And I'm going to use parentheses on both of those because the endpoints are on the x-axis. Okay. Let's see, Trendon, what is my x-intercept for this problem? Or intercepts. There might be more than one. as a hint. Okay? Give me the coordinates for that. So what are they? 6, 0. So 6, 0. That's this point right here. Okay. And Gage is still in Trenton's glory, but he is correct. -2, 0. Okay. Avea, what is the y-intercept for this one? It is at -2. What are the coordinates of that point? Like 0, -2. The 0 comes first on that one. Okay. Now, this one's a little bit different as far as absolute maximums, minimums, and stuff go, right? Because your absolute maximum looks a little different than it did on the last problem. Anybody think they know what the absolute maximum of this one's going to be? What? 2. It's this point right here. Okay? So the absolute maximum is 2. Or you could call it 8, 2 if you want to give the point. And then there is some debate on whether or not we should call that a relative maximum because it's at the end. Depends on which definition you're using. I'm just going to go ahead and call it a relative maximum just because I've told you they're always the same. Depends on the definition you're using, but we're not going to get into those level of detail. So for example, rectangles and squares, right? A square is always a rectangle, right? If you have a square, it's always a rectangle. But are all rectangles squares? No. So absolute maximum is kind of like your square. If you know it's an absolute maximum, it also has to be an absolute minimum. Or absolute relative maximum. Oh, that is a much larger, like the debate on whether or not you count the endpoints is, or like whether or not you use parentheses or brackets. It's really like a calculus argument that has to do with like all these like formal definitions of math, and trust me, you don't want to get, if you want to stay for EHS time, I'll gladly explain it to you. But I don't want to spend class time on it because we talk about it in detail a little bit in calculus, but unless y'all are signing up for calculus, I don't want to get into that one. So, all right. Okay, then absolute minimum. Alex, what's our absolute minimum for this one? Absolute minimum is the very lowest point. Yes, very good. So it's right here. You could either just say -4, just give the y coordinate, or you could say 2, -4 for that. And since that is a absolute minimum, it's also going to be a relative minimum as well. Do we have any other like relative minimums or maximums? Not really. Maybe this endpoint, depending on the definition you're using, but I'm not really that concerned with that there. Okay. Okay. So that is all.